Hello, children. It's been a long time since we've spoken via video. So, today's lesson is about what's called an existence theorem. So this doesn't actually give us an answer, it just tells us if an answer is to be found somewhere. Okay, so the first thing I'd like you to think about is consider a polynomial function. What is the domain of a polynomial function? I'll give you a few seconds to think about that. What is the domain of a polynomial function? Okay, so with luck, you all shouted at the screen, all real numbers, or some of you may have even said negative infinity to positive infinity. And you are correct. That means that a polynomial function is continuous from negative infinity to positive infinity. All right? So I want you to think about something else. Let's say that on a graph, and you might even sketch these 2 points and then consider the graph between them, remembering that the domain of a polynomial function, of every polynomial function, is all real numbers. So suppose that you knew that f of negative 1 equals 8 and f of 1 equals negative 6. So maybe you could just take a moment and sketch what that might look like. And then think about what you know about the function as a result of that. You can pause the video if you want, but I'm kind of giving you some time here. I'm going to sketch it myself. F of negative 1 equals positive 8. F of positive 1 equals negative 6. Okay? Well, we know that between negative 1 and positive 1, there's going to be a 0. Sorry. Because my function is continuous. So my function could do anything else out that way. It could do anything else that way. But we know that between negative 1 and 1, somewhere there's a 0. Do we know that it happens right here? No, we don't. It could go there. It could go there. Okay? Those are possibilities. But we know that the function is going to pass through the x-axis. We are certain of it. Okay? This particular observation or fact has a name. I like to abbreviate the IVT, which stands for the intermediate value theorem. Okay? The intermediate value theorem. Intermediate sort of meaning between the two. So what this says that if f of x is a continuous function, and come on, Lagreen, let's go. If f of x is a continuous function, and there is a sign change between f of a and f of b, then there exists a 0 between a and b. Okay? So let's just sketch what that means. So let's call this a, and let's call this b. And there's a sign change of the function between a and b. What that means is, for certain, if the function's continuous, is that there's a 0 between a and b somewhere. Okay? So this seems kind of like, what I was saying about the 0 function. It's just that 0 times anything is 0. I kind of thought that was a silly thing to say, and you might be thinking, well, no, duh. But so let's just show you what that looks like when you're proving it. Show that f of x equals x cubed plus x minus 1 has a 0 in the interval 0 to 1. The first thing I need to say is f of x is a continuous function because its domain is all real numbers. Okay, all polynomials are continuous. Second, I'm going to show that f of 0, I'm going to evaluate, is -1, which means that f of 0 is less than 0, right? It's negative. And f of 1 equals 1 plus 1 minus 1 is positive 1, right? Therefore, f of 1 is greater than 0. So since it's continuous, and there's a sign change between the points x equals 0 and x equals 1, therefore, there must be a 0 between x equals 0 and x equals 1. And that is the intermediate value theorem.